For the CLEP exam, there's not a whole lot to say about these. The types of techniques we had for quadratics, like simple factoring and the quadratic formula, do extend to higher order polynomials, but they are harder to use. Okay, so in particular, I'd like to draw your attention to something that's not really covered on the CLEP, but that I think is interesting to know, which is that there are things like the quadratic formula for degree 3 and 4 polynomials. That is, you tell me the coefficients of the polynomial, I tell you where it's equal to 0. Nothing like this even exists for degree 5 and higher. So this might give you some sense for how things get a little weird. Okay, I just want to point you to this and make a shout out to a really great theory of mathematics called Galois Theory. Okay, of course, this is typically covered in a PhD program in mathematics, not something that we need to be concerned about here, but I think it's nice to know that, you know, there's not a whole lot we could say even if we wanted to. Things just get a little bit too complicated to talk about. So let's look at an example of factoring a higher order polynomial. Okay, so here's a nice one. It's just x cubed minus x. So in general, how do I deal with a degree 3 polynomial? Well, we are definitely not going to memorize the formula for finding roots of this. It's much more complicated than the quadratic formula, so we have to try and play some games. So the first question we ask is, are there any obvious moves? Are there any obvious things I can factor out here? So take a look at what we have, right? So anything that clearly I can suck out of both x cubed and x? Well, in fact, yes, I can factor an x out of this and get x squared minus 1 left over. So for those of you at home, you can check this just by multiplying x squared by x and minus 1 by x. And now I can address this, which is not too bad, right? It's actually x plus 1 times x minus 1. Okay? And of course, this is now finished, right? This is completely factored, and we can check that this works in a couple different ways. Let's check it like this. Okay, we'll distribute to the x to x and 1. And so here we'll get x cubed plus x, minus x squared plus x squared minus x. So I get x cubed minus x as necessary. Okay, so in this case, we were able to factor the polynomial pretty easily. In general, it's hard to do this for higher order polynomials, by which I mean order higher than 2. So look for tricks, look for obvious things to factor out, but other than that, there's not a whole lot we can say.